Hello all, welcome to a new video on logic design. Today we are going to learn a new topic, that is K-map or Karnaugh map. K-map is used to simplify the Boolean expression. Instead of using the laws and axioms of Boolean algebra, we can easily use a K-map to simplify the Boolean expression in a GATE exam or any other competitive exam to save our time. If you are new to my channel, check out my videos on the selected topics from the course of Logic Design and a few videos on the solutions of the previous year question papers of Logic Design. The links of all those videos have been given in the description box. So in this video, I'll be explaining about a two-variable K-map, that is how to map the expression in a two-variable K-map. So without further delay, let's get started. In a two-variable expression, we can have 2 to the power of 2, which is equal to 4 possible combinations of the input variables. So let that input variables be A and B. And the combinations of the input variables are A bar, B bar, A bar, B, A, B bar and AB. So these are the 4 combinations. These are called as minterms. There are 4 minterms here, A bar, B bar, A bar, B, A, B bar and AB. These are called as minterm. Now instead of representing the minterms in terms of the input variables, we can use the shorthand notation. That is, for A bar, B bar, we can write M0. For A bar, B, M1. AB bar, M2 and AB, M3. Here when you write the shorthand notations, like for example, A bar, B bar, here the literal A is represented as 1 and A bar, that is literal with a bar, is written as 0. The literal without bar is written as 1 and the literal with a bar is written as 0. Therefore, for A bar, B bar, we can write 0, 0, which is equal to M0. This is the decimal designation of A bar, B bar, where the letter M is the minterm and the subscript 0 is the decimal designation. Similarly, you can write the decimal designation for A bar, B, where A bar is 0, B is 1. This is M1. Similarly, for AB bar 1, 0, that is M2. And AB is 1, 1. The decimal designation is M3. So now, if we consider the expression F is equal to A bar, B bar plus AB bar plus AB, we can express this using the minterms as capital F is equal to M0, that is for A bar, B bar plus M2 plus M3, which is equal to summation M0 to 3. We can read this as the sum of minterms 0, 2 and 3. Now we can represent this in a truth table. For writing the truth table, we can write the minterms in the first column, then the inputs A and B are the inputs here, and in the next column you can write the output. So which are the minterms here? 0, 1, 2 and 3 are the minterms, and which are the combinations of, which are the 4 combinations of zeros and ones? That is the input 0, 0, 0, 1, 1, 0, 1, 1. Now, which are the minterms present here in the expression? We can see 0, 2 and 3 are the minterms which are present in the output. Therefore, mark the output as 1 in 0, 2 and 3, and whichever minterm is absent here, we will give the output as 0. So this is the truth table Now let us see how to map this SOP expression. A two variable K-map has 2 to the power of 2, that is 4 squares or cells. That is, this K-map consists of 4 cells, that is 2 rows and 2 columns. These are the 2 rows, zeros and ones, and 2 columns, 0 and 1. These are the variables A and B. How many cells are there? 0, 1, 2, 3. 4 cells are there. Now we can write the minterm designation of the squares. So the first cell is A bar B bar. The minterm designation of the first square is A bar B bar. Second is A bar B, and this one is A B bar, and the last cell is AB. Cells or squares. Now according to the example, that is summation M, minterm, sum of the minterm 0 to 3, sum of the minterm 0 to 3. These minterms are present in the output, that is M0, M2 and M3 are present in the output. Therefore, you have to place ones in those corresponding cells in the K-map. And whichever minterms are absent in that corresponding cell, you have to place zeros or you have to leave it empty. So let us draw the K-map once more. 0, 1, 0, 1. Here 0, 1, 2, 3. 0, M0. M0 is present. Therefore, you have to mark, you have to place a 1 in that corresponding cell. M2 is present. Place 1 in that corresponding cell. M3 is also present. Place 1 in that corresponding cell. Here M1 is absent, so either you can leave it empty or you can place 0 here. So this is how you map the sum of 0, 2 and 3. The sum of the minterms 0, 2 and 3. This is how you map. So let us do a simple example here, that is to map the expression f is equal to a bar b plus a b bar. So the given expression is in SOP form. So we have to write the expression in minterms. So for that, a bar b, what is the minterm of a bar b? As I told, the literal with a bar is represented as 0, literal without bar is represented as 1. Therefore, this is M1. This is the minterm of a bar b. What is the minterm of a b bar? It is 1, 0 means M2. Therefore, when we write this given expression in minterms, we can write f is equal to M1 plus M2, which is equal to sum of the minterm 1, 2. Now we can draw the K-map. The two variable K-map consists of 4 cells, 0, 1, 2, 3, 4 cells, 2 rows and 2 columns. So which are the minterms present in the output? 1 and 2, that is M1 and M2. M1 and M2. And whichever minterms are absent here, we can mark as either 0, we can place either zeros in that corresponding cells, or we can leave it empty, or you can mark as 0. You can place zeros here. So this is how you map the SOP expression.